Good morning, class. My bracket is officially busted. Every year I have such hope. I think, I'm going to go all the way. And then by the end of the final weekend, or the first weekend, I am out. So much for Virginia. Okay, anyway, let's get on to some math. Lesson 3 of chapter 11 is called Simplifying Rational Expressions. Rational expressions are just, they give you a definition there. It's an algebraic fraction whose numerator and denominator are polynomials. 2 over x minus 1, something like that would work. First thing you're going to do is you're going to figure out excluded values, like what we've been practicing in the last couple of lessons. So we would write, after we wrote that, we would write x cannot equal 1, right? So that's an excluded value for this. And then we would go through and we would try to simplify. Now in this case, there isn't going to be any simplifying. But let me just remind you what simplifying fractions entails. If you had something like 4 over 8, you've done this for so long that you just almost automatically see that as 1/2. The problem is that you're going through a couple steps there in your mind that I want to remind you of. What you're doing is you're actually rewriting this as 1 times 4 and 2 times 4. You're basically pulling out a common factor from both of them. And actually, if you can do it the greatest common factor, you're pulling that out. And then you're rewriting it as something times that greatest common factor, something times that greatest common factor. Now, you know that if you have the same thing over the same thing in a fraction form, that just turns into a 1. So this is a 1. And 1 times that is just going to give you that. So that's kind of what you did when you simplified. Now we've practiced it with variables too. Okay? If it was xy over x squared y squared, we just kind of basically rewrote this bottom one. We left it as xy, and we rewrote it as xy times xy. We simplified that. That turned into a 1 above xy. Now we've done all that. This is going to be just a little bit more than what we've already practiced. Look at one of their examples, letter A. It's on page 690. Is negative 8 over r squared minus 36. Now, first thing you're going to do is you're going to say, okay, what are the excluded values? Now, it's a little tough to see here, but if we rewrite it as negative 8 over r plus 6 times r minus 6, which you know how to do because this is the difference of two squares, then you can see the excluded values in this case. Remember, it's anything that can't make this equal to 0. So if r equals 6, that would make that equal 0. No, sorry, that would make that equal to 0. And if r was negative 6, that would make that side. So r cannot equal 6 and negative 6. Does that make sense? All right. Now, in this one, we can't actually simplify. Let me rewrite this a tiny bit. What if I gave you r plus 6 over this? Well, first you would break it down. Now we would be left with an r plus 6 up here. At first, it doesn't look like you can simplify anything, but now you'll see that you have a common factor. You have r plus 6 over r plus 6, and this is times. So this is a factor, so we can get rid of that. Now you can't just leave nothing up on top. It can't be blank, and we'll have r minus 6 down below. So you put a 1 as kind of like a placeholder there. Does that make sense? Cancel, you're left with r minus 6 down below. You need a 1 up above, and that's how you would simplify that problem. Okay, and those are your excluded values. Let's try another one. Let's look at example 4. It's 2r plus 18 over r squared plus 8r, r squared plus 8r minus 9. This is on page 692. Okay, so why don't you try this? I'll stop and you try this yourself. Figure out the excluded values and then try to simplify it. Okay? You do that while I ponder what I'm going to do next year. Okay? Okay, how'd you do? Well, let's first work on getting excluded values. And usually you're going to have to factor this. I don't know if I should say usually, but sometimes you'll have to factor this. Okay? So let's look at this bottom one. And we could factor that into two binomials. The factors of r squared, of course, are going to be r and r. That tells you that the signs are the opposite, and the greater majority of them is going to be positive. Factors of 9 could be 3 and 3, but I think it's going to be 9 and 1 in this case. I want the majority to be positive, and then so I can factor it that way. Okay? Hopefully you all remember how to do that. And then on top, we have 2r plus 18. That's going to factor. Do you see there's a common 2 here? So if I pull that 2 out, it's going to leave me behind r plus 9. So first, let's deal with excluded values. Do you see that r cannot equal negative 9? Because that would make that 0. So r cannot equal negative 9. And r cannot equal 1. So there's your excluded values. Hopefully you got that. Now do you see there's a common factor here? That over that is just going to go away. And you're left with 2 up above and r minus 1 down below. Okay, did you all get that? I hope so. Let me point out one common error that people do, and it happens so often that it's made me lose my hair. You cannot factor when you're like adding, like if it was 1 plus x over x, you cannot cancel that. That is not a common factor up here. You're adding it to 1. You're not multiplying it by 1. If it was 1 times x, of course you can cancel it. But just think about it. Think about it without variables. Is 1 plus 2 over 2, can you cancel that? And is that the same as 1? Of course not. 3 over 2 is not the same as 1. So you cannot just cancel things just because they're on top and bottom. Please don't do that. They've got to be common factors. What about 2x over x? Can you cancel that? Yes, of course you can. But see, if I add this in there now I can't do that anymore. Because x is a factor here, but it's not a factor here. It's just not going to work. Any other examples we need to do? I think that's it. Okay? Oh, no, it isn't. I forgot on page 693, they talk about what the zeros of a function are. Okay? Remember, remember when you were graphing parabolas, the zeros of a function are wherever it crosses the x-axis at. The way you would do that is look at the function they give you on page 693. They say f of x equals x squared plus 3x minus 18 all over x minus 3. Hopefully you can see excluded values are going to be x cannot equal 3. We're going to replace this. We could replace it with a y, but in this case we want to know when y is 0. In other words, when is it not above the x-axis? So let's replace that with 0. You know what? I'll just do it here. And then you're going to have to factor this. So make it x plus 6, x minus 3, all over x minus 3. You're going to cancel there, and you're going to be left with x plus 6 up above. Now, Basically, think about your equation. It's going to be x plus 6 equals 0. So the 0 of this is, we'll solve it, and x is negative 6. That's where your 0 is at. Okay? All right, that's all there is for simplifying rational expressions.